This is the Amp Hour Podcast, released March 21st, 2021. Episode 535. Efinix FPGAs with Sammy Cheung. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
Hi, this is Sammy Cheung. I'm the CEO and co-founder of Efinix.
Hey, Sammy, how are you?
Pretty good. Thank you. How about yourself?
Oh, I'm great. I'm excited to talk about FPGAs. I love talking about FPGAs on the show. Some of it because I have lack of knowledge, and I love learning from experts such as yourself. And some of it just because I feel like FPGAs have been on the cusp of being that thing that's in everything for so long. And it feels like with Efinix, it's like, yeah, we might be getting there. You know, we're an FPGA in every device. Is that kind of the goal of Efinix, or how do you see FPGAs in the marketplace?
Absolutely. You're right on. FPGA has been around, about 30 years plus, and it has been really a great niche market, but it has never been like a mainstream product like the application processors, microcontrollers. And what we are seeing today is what Efinix bring on the table with our disruptive FPGA technology. We can become the mainstream product drivers, and we can see that in the next decades and next couple decades, our device and technology will be everywhere. That's how we see it.
Yeah. Yeah, I mean, and Efinix hasn't is a relative youngster in the market. I mean, you haven't been around that long. So how did everything get started? Where did it? I mean, for a long time, it felt like there was only a couple of FPGA companies in the past couple of years. I feel with fabless technology, it's possible to get more out there. But companies like yours are doing this interesting new model and new market. So what was the history of getting to where we are?
From focusing on building products, we actually start more in 2017, but the company itself was originally started back in late 2012. So at that time, myself and my co-founder, business partner, Mr. Tony we came from an area we both worked in a famous Altera in the past, and we felt like the industry never really grow bigly, and there's got to be way to make the technology a lot more efficient, a lot more usable everywhere. So, and we believe at the time of our career is a good time to try something new, open up a new company, and start to bring some idea and the technology to build something really from scratch. That's how we started. Was very simple minded, very straightforward. I still remember the original goal Tony and I shared in some way that it's kind of like a curse that we understand the industry and the technology well, and it almost even before we start, it already telling us it's impossible to build a full-blown real FPGA business. So our original goal was really try to build a technology and work on a few license possibility, and expected we will get acquired within a short period of time. So we work on it with less than 10 people. We really build up the software and early prototype devices. And we were really getting tractions from big companies want to license our technologies, and go to the point to about 2015, we have multiple possible acquirers. I also know that there were deals on the table, but life never that smooth as what we would like, right? So
That's right. Right.
something happened, and in that year, Intel acquired Altera. At that time, it was like pretty big, shocking news. It was very clear that FPGA wasn't just a general purpose logic device. It's being used in data center. It's being used in the future for all the data processing. Now we understand for AI as well. So our potential acquirers, because of that reason, actually paused. So it was disappointed for us, but we actually push us to go for a different path. So eventually, I think we continue to sharpen our technology, and there was a breakthrough in 2017. We actually courted investments from pretty big names. Interestingly, one of the leading investor is Silence. Everyone knows our number one leader in the
Right.
industry.
Right. So a potential competitor, like is just like, hey, yeah, we'll help we'll help build you up for someday.
Yes, yeah. I think that I had questions every week about why they were doing that. And in parallel, Samsung also invested in us that year together with a
Yeah, that makes more sense though. Like Samsung, I could see using your parts and being that could be a
right.
strategic thing like that. But Xilinx is like, oh, okay.
I wouldn't interpret that there was never an exact reason for that, but I really appreciate the opportunity Silence gave us. I totally looking at it as a big vision thoughts, very open mind thoughts about investing in a technology that they view has a strong potential. But it's not surprising that, I mean, no one would thought this technology can evolve to build a full-blown product company within 3 years.
Yeah. Yeah, if we could take a quick step back too. So, I mean, we say start an FPGA company, but like how does one actually do that? Is it basically like hire a bunch of chip design? I mean, it sounds like Tony, your co-founder as well. He had a lot of architectural experience, but is it basically like get a couple people together that know how to build like a chip cell and start to actually just then you just ship it off to a fab house, or how does that actually go?
That's actually a lot more complicated than that, and that's why FPGA is a business that very hard to penetrate and make it good. I mean, the first
Mm,
lowest level is
yeah,
really required the three pieces: architecture, software, and the most crafty IC design. So these three has to work concurrently, cohesively to make the best products or technology. So it doesn't.
yeah,
Some people come from ASIC world, some people come from EDA world, and if they try to work things sequentially, the device they're building up probably like 2x, 3x bigger than the most capable FPGA, right? So these are the three fundamentals,
hmm,
and the software is not just like GUI or interface. Is really the guts of the
right.
algorithmic placement and routing and fitting.
Right. Well, and the user experience too. I mean, I just think about my younger days working on FPGA software, and it's just like it comes in a lot of different flavors, but a lot of it was just very slow and kind
Sure.
of difficult to use. So it's an important. It's like the first thing your customer sees.
And it all starts with the technology and architecture, and there's a term called fitting, right? So it all depends on how hard you can make your design fit and stuff into a FPGA. That's the first level. And then the complexity arises, right? When you go up the second level, now if you want to build a real chip, you have to really understand how to integrate other intellectual property around your chips, how to bring it to productions,
Oh yeah. Yep.
and then we need to build up an ecosystem for all the soft IP inside the core. And then on the right hand side, you have the build sales channel, market it, and then this kind of investment will kind of increase exponentially if we try to increase complexity. And the most
Yeah.
discouraging part for people who start FPGA business was you can build one product or one chip. After that, if you're a startup, you probably spend most of the money. You can't even build a second chip, or not even think about building a second
Oh, yeah.
generation of products. That's the killer for most of the startup company tempted to get into FPGA,
Yeah.
right? So it's the
Right.
complexity is a lot higher. Well, I think what Efinix has done, it's kind of broken a lot of old assumptions, rules, and as I mentioned that within less than 3 years, we brought up a full-blown FPGA product family called Tryon, and it's all in production. With only less than 1.5 years in full productions, we sold over 1 million units, even when we were crossing
Yeah.
pandemic.
That's really impressive.
Yeah,
Yeah.
so we are still doing something that people start thinking, how did you
Right.
do that? What do you guys eat, right? So yeah.
Right. Yeah. And so I mean, you mentioned like a lot of startups too. It's tough to get to that second chip. So do you find that the first generation has to be super targeted at a certain application space to try and like really find like a niche that is like really well targeted, or is it possible to make one that is more general purpose and then just hopefully you get enough traction and enough you build out enough user base so that people are like, yeah, we want more.
I think it's actually a trade-off of both. In our old days, we have been building FPGA so long, right? We usually said all the FPGA are kitchen sink. They basically you put all the features, take
Yeah.
2 years to
Right.
define, take 3 years to build, take 3 years to design. So almost like only 10 years you get the revenue, right? So that's why it's not growing, right?
Wow.
So and on the other hand,
Hmm.
if we try to build a one solution market ASSP, then you put a lot of pressure on your marketing, your crystal ball, right? Is it a real market you want to do it?
Right. Right.
So I would say the answer
Right.
is you get it somewhere in between. Like for example, for us, right? We are not going to be an ASSP company because we didn't build from solution driven. But on the other hand, we have to pick a
Hmm.
couple markets with the right intellectual properties and the right customer targets to start, right? So for example, we are Tryon currently is super successful in surrounding computer visions and also intelligent
Mm,
sensing.
yeah.
So we're doing very well in industrial cameras, all types of visual cameras, which usually combine with integrating multiple sensing into the same platform.
And is that because you have peripherals in there that might be more targeted, like towards cameras and vision, kind of the high throughput kind of stuff?
Yes, I think the combination of having a MIPI interface and also have strong enough in terms of the memory bandwidth. And also, one critical thing is our technology because the newer applications in computer visions, whether it's industrial or smart home, they require a lot more logic elements to processing. They are not a bridge device. They want to do some low latency computing processing near the sensor.
Hmm.
And
Yeah.
also emergently, people would love to put a reconfigurable neural net, small things, not the big one, for some inference
Sure. Yeah.
function integrate
Right.
with custom functions. So they find it very handy, especially they never saw a device like 120K LE device in Tryon that can fit in such a small package and also low power. So and keep in mind, it's not just
Yeah.
one thing; it's a combination of all low power, small form factor,
Yep.
a lot of logic elements, and also we price it right for everyone. So the camera guys love
Yep.
it. I mean, anything that doesn't need necessary camera, right? It could be a smart home equipment or things that with multiple sensors and they want a path to scale their processing and they like us. So that's how we
Hmm.
really started that way. And I think we nailed it, but on the other hand, it's still an FPGA.
Yeah.
We sell it to many different things. So not necessarily just computer vision, right? So that's kind of like a hybrid approach. And but I could share with you the our top customers are all someone playing with computer vision. So yeah.
Ah, interesting. Okay. Yeah, I mean, it sounds like, I mean, it's like the what I heard from what you were saying there is it sounds like when an engineer is doing a trade-off analysis of like, oh, part size, power, how many logic cells I can get, what is, like it's tough to do that comparison. And if you're in the running there with like having a lot of those in the green, having the green cells on the Excel spreadsheet, that's what I think about because I used to do those, comparisons. If you're lighting up a lot of those cells green and they, you're really winning in a lot of these things, that that alone is kind of like a product speaking for itself, I think, because it sometimes then if an engineer convinces themselves that like, oh, I definitely need all these things, and the Efinix the Tryon part like offers it, it's like, oh, well, there's the answer. That's great.
You're right on, Chris. We never had the most splashy marketing things we did. I mean, we run it very organically because we still have a much bigger story coming up, which we talk about it later.
Yeah. Yep.
We never had like the top influencers talk about that every day. So, but I think yes, the device actually pulling the whole company. And I think out coincidentally, there's few threads how our top customers use us. They share the same traits. They are big size companies, but they are still driving very hard, very still innovating. They have a spec very hard to meet with ASIC nor traditional FPGA. When they find us, they say, "Oh, this is it." So what that means is we
Yeah.
win
Right.
truly by the disruptive nature of the technology and the combination of the product's definition. And the story proliferates. Once you got the big guy using you, the industry start knowing that. And everyone say, oh yeah, I never saw this before. Now I should find a
Mm-hmm.
way to do things differently. In the past, I thought about FPGA it just for prototyping. Actually, some of my smaller customers had a tough time working with FPGA because they need to innovate with FPGA, but the price cost power would never allow them to survive. So
Mm-hmm.
they
Yep.
when they see us say, "Oh yeah, we can innovate with you guys." So but we should better now with the product pulling us together with focusing on more the leading innovating company. But as time goes on, I believe once
Mm-hmm.
everyone recognizes it, so our name and how to use us will proliferate pretty fast, right? So
Yeah. Well, and you mentioned too the fact that a lot of your customers are using computer vision. I mean, that is that is an area of growth that's just not slowing down in the slightest. It's just crazy how much that's going into a variety of products, even outside of just a industrial camera type of thing. But just putting vision into industrial uses or consumer uses, things like that. It's just it's a really interesting growth area.
absolutely, I think we kind of arrive nothing like really like a grand planning 3 4 years ago. We just arrived at the right time, and
Right, right. You put the right IP in there, and it's got all the bits and bobs that are needed, and people are like, "Yeah, I can use that. Okay, cool. Let's do this."
exactly. But everyone knows that building ASIC is astronomically difficult.
Yeah, right.
So when someone pick up a FPGA device, which very capable, and we price it right, and they can go to millions of unit production without a sweat. So they will be putting the bet easily on us to use us, and so we kind of
Hmm.
changing the
Yeah,
game quietly, and but it of course it won't be quiet in the next few years when more people start knowing about it. So
right. Well, hopefully now the amp hours you're going to point to that and be like, "Oh, well, that was the inflection point right there." A
yeah.
bunch of engineers listening about it. So you'd mentioned the technology, like the underlying technology. Can you tell me about? So this is, I think, some of what you said, like Tony and the architecture side of things, but making it so that it could have many logic cells in such a small package size. So what is it under the hood that actually allowed this to happen?
In simple terms, that I mean, the traditional technology, basically everyone is using it other than us. They are more, make it simple. It's all about logic, element, and routing. I'm simplifying it. And they are built from a spatial perspective are two different pieces of hardware. So in the old architecture, someone has to have a definitive count in terms of logic element and routing switch. And the only way when they scale the technology to be more higher density is to make sure that the routing switch has the routability to cover it. And
Hmm.
that's work very well during the days when I was in Altera. Is you shrink the technology, you use hire a lot of software engineers to optimize 5-10% a year 2 years to optimize the routing, and you hire a great IC designer to make it 5-10% smaller here and there. So then whoever execute well, which turned to be Altera and Silence, they won. However, you could see Altera and Silence both have been acquired by someone else, right? So clearly, we could see
Hmm.
they walk in the path building very expensive devices can only serve very expensive market, which is data. Yeah,
Right. Yeah, I think about those, yeah, servers and data centers and things like that. It's just these like monster heat generators, you know?
yeah. The technology forced themselves into the market that they couldn't return to build something much smaller, much more efficient, much more low power and scalable. So that's the key.
Mm,
And in the industry, there were a lot of peers try to build something small, but they more like trading off to make a bridge devices. And as I said, the main
hmm.
target market we are focusing on is really something high density but very low power, very small package size, and which actually
Yeah.
coincide with this big super hype of edge computing, right? So that's
Hmm.
what we are
Yeah.
building. So basically, our technology, the main difference is we have a cell defined called SLR cell. Basically, is someone can call it a fine grain architecture. So this particular cell is very small relative to what is built in a standard FPGA, and it can be reconfigured into either logic elements or routing. So what that means is
Yeah.
we can use software reconfiguration to determine routing based on customer design. And then in the process of building the architecture and the implementation, we very much could throw away 20 years of fat that built in the traditional architecture. So the net is get
Mm,
out of the gates. We running about half this area of what's the best in the industry and the best in the industry, and then whoever second or third, it's somewhat quite bigger than the best, right? So we are from an area perspective, from the core, it's very small.
yeah. So this is the XLR, right? The exchangeable logic and routing cell. Is that right?
Exactly.
Yeah, so I'm looking at there's a Spectrum article I'll link in for people to view. There's a nice graphic in there, kind of showing the crossover. What actually allows you to do that? To actually have the routing matrix and the logic element kind of be combined into one spot? Is it like a fundamentally different cell than before?
I think so. Yeah, it's a fundamentally different cell. I think the most important is not too much about hardware. I think the thought process is really on the architecture and how to make the software work. I think the hardware side always built from gates, transistors, and so on, and configurable elements. But the way the
Yeah.
structure is, the way how we organize is very clear, very different from traditional.
So there must be like a trade-off, though, right? So what is the actual trade-off to having now signals being routed through a cell versus being routed elsewhere? Does it mean that you have fewer logic elements available if you have a more complicated routing?
Not really, and the reason is each of the cell it's a lot smaller than the traditional unit. As I mentioned, part of it is we don't need to follow the 20 years accumulation of facts or rules that to build a traditional. So we actually have we have many maybe give a number. we have a lot more SLR cells on the chip than what we quoted as logic element count. So yes,
Oh, okay. Yeah, it's always like equivalent logic elements. I feel like there's like this push to try and get like apples to apples comparisons between different FPGAs, but it's always so tough to do.
exactly. You got it. So one of the things that people love to say that is, oh yeah, this architecture can make small and low cost, but performance must be bad because you do this route through here, this and that, blah blah blah. But they really didn't know exactly what we were doing, right? So for Tryon, it's clear was
Hmm.
targeting at because it's a 40 nanometer low power process. It doesn't run like super high performance. The performance is pretty decent. It's probably the top in that low cost, low power level. But when someone start looking at titanium
Hmm.
this year, we already sampling right now. The customer is astonished. So one of the customers told us that when they start try to run getting the software and running start getting on the development kit is like, are you guys serious? I run my RISC-V processor on Tryon is only 100 megahertz. It's 400 megahertz now. Are you
Hmm.
sure?
Well, yeah, I don't believe the simulations anymore.
So are you guys? Is it some mistake in your timing model?
Right. Am I actually gonna like see some weird bugs later or something like that?
Right. So how so this is titanium? Yeah, this is correct. We double check is correct. And how big the size is that
Mm.
60K LE device? What, 3.5 by 3.5? No way. It's impossible. So that's where we
Right.
are getting
Yeah.
out in the market right now. The architecture actually doesn't have a performance problem. It's just a choice when we pick a market
Hmm.
in a net, I think it is really a disruptive architecture. It's not a trade off. It's just a philosophical difference. Is we believe if we can make things more efficient, smaller, we can get rid of a lot of fat that would hinder the performance in a different way. When you make things simple, you get rid of a lot
Yeah.
of
Yeah.
parasitics, shorten the routing, and making things a lot more efficient. That's how we build up everything. So
That's great. Yeah, that's great. And so you mentioned the titanium. That's the new one that's coming out. So now you've gone from Tryon. That was 3.5 years ago. That was kind of your first offering. You got to the second offering. That's the titanium. That's the one that we're excited about. That we think is going to really be out in the world. What's actually different about this now? Like, what is actually a different? Maybe because we're already at the low level. What's different at the low level now? Is it just the process difference? It's a smaller node. It's a different fab, that sort of thing.
actually, under the hood is very different. I let me make sure. I don't know how much we disclose yet, but I think I can tell I'm the CEO, right?
Yeah, yeah. You're the boss, man. So you get to tell.
So I think this titanium we upgrade the architecture in a way that we did a lot of improvements in terms of connectivity and routings. The fundamental concept is still the same SLR, and also we add in some other features and enhance the system performance quite a bit. We classify as about 4x the performance improvement compared to Tryon. The fabric itself, it's major juice up in terms of performance. But the amazing part is we still can keep the area super small.
Yeah, I mean, we should talk about that too. I mean, there are some like really small. So we've talked about that on the show before, but to just step back to the Tryon real quick, the smallest one you have is a zero point 0.4 millimeter pitch 3x3 BGA. That's still it's a 49 ball BGA with 33 available IO. So like that's crazy tiny.
Right. We build those small devices, and most of it is get to the market pretty easy, and also can illustrate the trend that we see from the demand is the customers are looking for more than a bridge device. They want to put some
Hmm.
level of processing near the sensors, near the data coming in.
Got it. And when you sorry, can we define bridge device as well? So how would you define bridge device?
So bridge device is, for example, they may be using a few thousand lookup table to just do some simple functions. and they more focusing on the I/O,
Mm.
the interface, connecting device, for example,
Okay.
and AP is missing this I/O, they need I/O expander. So that's how FPGA was labeled in the past.
Yeah. Right. It's almost like a new version of a CPLD at that point, and using it that way.
Exactly, it's more like sometime in a mobile space, or they view it as a patcher. Few $100 million business, but it's come and go, right? So they don't stick. Except the CPLD
Yeah.
is different because they're non-volatile. So, but for us, it's different. We start seeing things that they need the reconfigurability, so they wouldn't be easy to change to ASIC or start with ASIC, and once they need to process
Yeah.
more, but they never had this kind of device before. So I think we are still scratching the surface. The market understand, whoa, this is different. So as I said, the trend and the situation favoring us when the world is still trying to find a perfect good solution for edge computing, and everyone say they're doing that. Actually, both Tryon and titanium would be the best fit into most of the system. I mean, just a disclaimer:
Yeah.
we are not trying to build like some. I mean, our respected FPGA companies. The culture is tend to build everything themselves, but we don't. We want to focus
Oh,
on
right. Right.
FPGA technology. So we actually, with that kind of small size, we are seeing growing big company want to partner with us. Microcontroller company, microprocessor company, sensor company, memory company. They all seeing that pairing with us, there's an advantage, and they also see that they can just buy die from us to build their own module products without really rebuilding a new
Oh,
chip.
okay. So they're doing like a SIP or similar, like a system in package type of thing.
Exactly. The simplest thing is just a SIP. And I envision that the for more high end in the future is what we call the chiplet, but they are same thing. I mean, they're multi chips to build a more complex module and system, and it
Hmm.
hitting quite well too. I mean, it's helping us, a small company. The old school is, oh, you need to hire 100 people to build a sales channel and see what happens. But now I think we are doing both our own sales channel, but some of these companies are very big company. They don't sell FPGA, but they will package us together, say maybe selling, I cannot tell exactly, but
Hmm.
they may sell intelligent sensors with a FPGA behind the sensor that you don't know. So yeah.
Yeah.
So
Right. Right. Exactly. Right. It's like this sensor's reconfigurable. How'd they do that?
exactly. So every sensor they sell, we have our own FPGA. So they are our channel. They are our partner. So
Oh, that's
they,
cool. Yeah.
frankly,
Yeah.
they couldn't package up the old traditional FPGA. Either it's too big, too expensive, too power hungry, or they are too small in
Yeah.
logic
Yeah.
density that doesn't serve the purpose. So now they find something very, especially
Yeah.
titanium, and going forward, right? I think a lot of people jumping on a ship right now. So
Does that mean that so those small like chiplet the chiplet style where like you're selling raw silicon to someone else who might be putting it into a SIP for like a sensor package? Does that mean that the Tryon or more specifically the titanium now does that do you have like a simplified like power setup as well? Because I just one thing I always think about with FPGAs is like very complex bring up of power rails, like tracked power rails as they come up, that sort of thing. And I'd imagine that if that was pulled into like a sensor package, that could be very complex. So what does the power look like on power bring up?
I think the power bring up is a lot more straightforward when compared to what you kind of perceive. The reason is the device with very complex power rail was more I would say, the last 10, 15 years when FPGA company, the big leaders, try to do everything themselves. So they stuff in a lot of
Ah,
different
okay.
power rail, different system onto the same chip. And because they make money out of
Hmm.
building chips, right? So, but for us, as I mentioned,
Right.
we are small. I mean, we don't go that route simply because it's not economical. And so we make our device simple to interface. So it's very, even with titanium, will be very straightforward to be integrated with other people's components. So essentially, that we probably expect we have a lot more friends than enemy. So we can call ourselves a companion device, coprocessor, but I think the real name
Yeah.
is really, in this new era, is a reconfigurable accelerator. We can
I like
accelerate
that.
the
Yeah.
sensor applications and usage being reconfigurable. Microprocessor application processor would love to see us to expand their feature set without keep tipping out expensive mask set. It's really time to market,
Hmm.
and we can sit right next to storage memory to make intelligent memory. So I can see there's variety of combination applications can evolve and put on top of it. And specifically, it kind of jump into a couple areas that is pretty significant. What I see is, especially with titanium, it's security, and also how we deploy the whole combinations of technology and ecosystem into automotive as well. So those are some of the areas we're pretty excited when we can see that our device, A is we don't need to carry the burden of our traditional FPGA company. We need to build everything ourselves.
Hmm. Yeah.
B, we find a lot of friends, and we can build a lot of, open a lot of market in parallel with different companies, and pretty much they drive the market. They find ourselves useful, and what we need to do is continue to make our architecture more sophisticated and continue to push out technology nodes, and of course improve our software usability and ecosystem. So that's how I can see that it is going to be a franchise that it's going to last for decades. So yeah.
That's great. That's a good to have that long term view too. I think that that sort of thing helps to give some confidence when like instead of like I've had vendors talk to me before. They're like, oh, I've got this hot new product and it fits all your needs. I'm like, yeah, it really does. And they're like, yeah, and we're doing all this other stuff, and then like then that company's gone in a year, and I'm like, oh wow, whoops, shouldn't have
Yeah.
designed that one in. Like, I didn't design that one in, luckily in my past, but like that's always a risk with like that's the hump you have to get over as the CEO of a smaller company to like convince people that no, yeah, this is a thing.
Yep. Yep. I agree. Yeah. It's also another thing is, most of the expectation is startup like us couldn't even make a second chip, but
Right.
in Tryon we actually tip out. I mean, it's public. People can figure out. We have four different mask sets tip out.
Oh wow. Wow.
Now titanium is 16 nanometer. I had an analyst talk to me earlier last year. I believe he kind of not believe in that. He said, no way. People couldn't jump into next generations, and not even talk about financing. It's hundreds of
Uh-huh.
millions to do that. That's what we were told by the FPGA company.
Yeah.
No, I spent very little amount of money to do
That's great.
that.
Yeah. Wow. FPGA
So
building on a budget, huh?
exactly. But I think that it is inevitable that we are at a stage that we will need to grow very fast, very big. And that's
Yeah.
probably the challenge for us. As I said, we know so much. I back in Altera, I sort of crossing space, running hundreds of people organization, building stuff from scratch. So I
Hmm.
know what it takes to build it up. But right now, I think we are kind of put our mentality. The whole company is really enjoying what we see. I don't know. I want to share a little bit about our feeling, or my feeling, right? So someone
Hmm.
asked me, what do I feel about being a startup CEO? I told them that I kind of feeling like a 15 years old boy. So do you know why? I explained to them that, I mean, the biggest challenge for me is how to keep our patience,
Yeah.
because
Right.
let me
To
share
not
the
go and
story.
chase every new thing, to not like
Exactly.
get dive into every exciting nook and cranny of the industry.
I try to use baseball as an analogy.
Hmm.
I kind of like a 15 years old young man, knowing that I can throw in average 100 miles per hour fastball, and my top speed is 110.
I've
And
seen this movie. It's a Rookie of the Year, I believe. It was a
yeah,
very bad Disney movie from the early '90s.
one of those. I'm 15 years old. I'm very eager to let the world to know I can do that. But the problem is if you don't prepare yourself to condition yourself well, to hang out with the right people, to sign up with the right team, your career can be over in 1 year, right?
Yeah, right. You'll burn out your arm.
Exactly. That's what we are
Yeah,
building right now is to make sure
yeah,
that we don't rush in some of the short-term temptations. Like for
yeah.
example, a lot of companies would say, why don't we just go after the low-end guy? They are easy to bid up and compete with them. No, that's not because they are good at that, we may lose to them. So I think we are really want to target at a market that it
Hmm.
was miserably missed by the big guys in the last
Yeah,
decade.
yeah,
And combining with AI and edge computing, we have a bright futures.
yeah, yeah. I think some of the features that you have on the titanium as well. I feel like that. Like if you talk about like setting yourself apart, you mentioned you don't want to chase the low end. You don't want to do it on price. I think that that's a good idea, just because it's. I mean, that's a tough business proposition no matter what. But then we've already talked about like having that kind of the green in every column kind of thing, and I feel like the some of the features that are in the family really helps too. So if you don't mind, I can list some of them here that like as you build up build up the family, there's like DSP blocks, PLLs, of course, GPIOs, high speed IO. I assume that's like SerDes style, DDR4 controllers, MIPI stuff inside, PCI Express, 2, 3, 4 lane, and then gigabit Ethernet, all internal actually to the part too. So you start to like reduce part costs. It feels like external. That maybe in an old FPGA you would have had to have controllers or things external. Now you can have that internally.
Absolutely. In some way that we are kind of have an advantage, sort of sit behind a market evolutions, and we have all these features built up essentially in the simplest way is when the density scale up, the interconnect, IO interconnect complexity increase. And also we would pick based on, of course, the market direction on some of the important features. We harden them in the IO side periphery.
Hmm.
But at the same time, in titanium, we want to point out a few things, and we still try to make the IO in a manageable flexibility. We supply multiple standards in terms of like the SerDes side in titanium, and then same thing for the MIPI. DDR itself is can support low power DDR 3, 4, and multiple different choices.
Yeah.
We maintain a good level of flexibility and try to avoid being kitchen sink. So that's how we try to draw the line. But on the other
Hmm.
hand, you mentioned about embedded memory and DSP. Those are not the good old simple multipliers.
Oh, okay. Not just like a Mac block kind of thing, or like a multiply accumulate.
It's combination of that as a basis, but it is very well in terms of tailored from some of the embedded AI applications. I mean, we are not building ASIC chip, but the main point for using our fabric DSP structure and embedded memory and to build embedded AI or embedded deep neural net is to give the flexibility in terms of building the varieties of choices of neural nets.
Mm.
DSP is very fracturable in terms of the nature. So those are some of the things that we actually I believe we haven't disclosed it. I need to be careful. So
Okay. Secret stuff. Okay, that's all
yeah,
right.
but
Yeah, yeah.
I think we probably will be talk about more starting in April.
Okay.
So the DSP functions and memory, it's very powerful. I mean, imagine
Yeah.
they were specially designed and specially designed in a way that it worked really well with our proprietary SLR architecture on the side, right?
Hmm.
So
Right.
all these thing is what we're offering is really a great 3-in-1. It's still a
Yeah.
FPGA. You can do general purpose custom logic. On the other hand, you can embed it a reconfigurable neural net implementation, and on the same chip you can do the native half low latency computing processing. So
Hmm.
we're still doing FPGA, but it's just disruptive in the nature that no one see. You can make it so small, make it so low power, can exist in different package, and then also with a good choices of IO interconnect. So we make it simple.
Hmm. How does an engineer then go and like actually? So you mentioned, we keep talking about vision here, and there's some secret sauce in the DSP blocks as well. Like what would an engineer need to do to actually like target that? Are there like actual specific vision packages, or is it basically like hook up a camera through the MIPI interface, and then it's, there's some kind of like configurator or something in the software
Yeah.
that allows you to target those DSP blocks?
Yes, I think there are, well, in the FPGA world, there are pretty standard way to design into the DSP block. It's kind of given that we are going to provide and working with our partners to surface it, not like need to wait. But on the other hand, we are actively building up what we call the soft IP offerings for our customers. So most of the cases, I mean, we see two different customers. One type is like some of the big company, they have very strong FPGA IPs people. They have all the IP themselves. So what we
Yeah,
need
yeah,
to
they just want
do
like a blank canvas to put their IP into, basically.
exactly, what we need to do is more at the tool applications level to help them to convert their IP onto our device. Which the
Hmm.
good news is we are still fundamentally a FPGA architecture by the look. So it doesn't take, it's not a very hard efforts to porting over to our technology in that case. I mean, like imagine someone invent a new AI chip of a totally different things. It's much harder to map technology into those kind of technology.
Yes, switching costs are always high, regardless. Anytime you switch a chip, I feel
Yeah,
like it's
exactly.
tough. But then when there's like specialized blocks or similar, if like someone's targeting a specific function in a well, like specialized block that some vendor might have, then yeah, you have to go and retranslate it to a new vendor.
Exactly. So we're a small company. I mean, absolutely from a tools IP ecosystem is very far away compared to Xilinx and Intel Altera. But we are driving very well, very focused on making sure our soft IP offerings to make it easier to use for customers who don't have like a large or FPGA design team. And so that's what we are working very hard on right now, because we know that titanium, it's the complexity a lot higher than Tryon. So the soft IP offering, which when I say soft IP, it covers all the way. Let's say the MIPI interface coming, the MIPI interface coming to a chip. Different customer may want different standard to work with the MIPI interface. Same thing for the working around the DSP block and embedded memory. We have the plan right now to offer some very standard examples in how to use those blocks together easily. And also, it is very important to mention that we didn't talk too much about in this talk is we have the soft RISC-V offering on our chip, which
Yeah,
was
that's great. I mean, I'd love to hear about that.
extremely successful in Tryon. And our approach is very straightforward. Is we absolutely leverage a very credible. There's no secret. We start with leveraging an open source RISC-V platform, working with them, and we make it a standard offering as a template, and we also make it look like a SOC template in a way that it's much easier for a lot of general customers. You just pick it up and use it. They can use the template, SOC template as is, or they can modify it if they like.
Yeah, I'm curious about that decision from a business perspective too. So like, some vendors also have like a soft IP block that is a processor. RISC-V is obviously hugely growing, and I love that. But a lot of times, they'll still offer like an ARM offering. I'm curious on the when customers come to you, are some like, well, we really want to put ARM in there. Do you have ARM offering? Is it Is there that question about alternative offerings? I guess Power PCs opened up a little bit more recently, but what's your view from the top, of seeing what customers are asking for?
I think that RISC-V clearly carrying a big hype in the market space, and also for Efinix in what we call our own offerings is RISC-V based because it's easier, much easier for us to access and develop the template and the platform. But I think the key word is still need to come back to, you can see from our website, the gut of the template is actually what we call the quantum accelerators. So, and remember, quantum is our marketing name for our technology. Accelerators means we make our fabric as an accelerator setup next to a RISC-V processor. Having said that, I may I need to be careful because the reality is our technology is agnostic to processors.
Got it. Okay. Yeah, I mean, it's any kind of like generic fabric, like FPGA fabric. You could put any processor you define in Verilog or VHDL. You could instantiate, right? But it's more about buying. Is when you're buying someone else's stuff, or you're using open source or open ISA type things, then it's
Yeah,
a better starting place, better tested.
exactly. So, and what we see at least in the next 5 years, I know for sure that probably will have other processor offering. Not necessarily we have time to build all of them, but I can see that some of these processor company are very willing to port their processor onto our quantum accelerators.
Hmm.
On top of it, I think our philosophy is not trying to build mixing up the same chip with like some kind of generic hardwire processor subsystem. The main reason is
Right.
if you look at titanium, if someone optimized well, you can run processor at 400-500 megahertz.
Hmm.
So you don't necessarily build a hardwire system, especially when you have so much more logic gates in the same area. So, but our focus is actually encourage partner or potential customers to look into what we call domain specific SOC. So that's the area. It's like if someone really pushing for much high performance, but they need FPGA technology, they can work with us by either two chip or single chip to put their subsystem domain specific subsystem design and merge it together into single product offering.
Yeah.
So those are not that complicated. It's only because it's a much bigger investment. So from a company perspective, we focus all mostly on a soft core kind of approach, especially titanium. When we see it can run 400-500 megahertz, is probably more than enough to serve the market we are targeting at. So
Yeah, I can see it. I mean, it feels like it's kind of another tool in the toolbox of like, okay, well, you have firmware engineers, you have software engineers, you want to be able to, instantiate a Linux system or maybe a low level real time operating system, just something to handle it in a traditional, with traditional firmware and things like that. It makes sense to have a targetable RISC-V processor. I am curious, one you chose was by Charles Papon.
yep, Charles, yeah.
It's from, they won a contest in the soft CPU contest in 2018. That's really interesting that it's like, oh, win a contest, get in, become like the chosen FPGA of, or sorry, the chosen core that targets an FPGA. That's really cool.
Yeah, I think so. I think it's all about timing. We are very grateful that we met up with Charles and we find a time and find that it's interesting to work together. I mean, we
Yeah.
still, of course, I mean, majority of the things we still putting back to GitHub and open source. As I said, we are not trying to take it too proprietary, and quantum accelerator is still very much agnostic. I kind of not surprised in this next few years, some people may take the concept to build their own can master. I mean, as you are aware, RISC-V have custom instructions And
Yeah.
if you blend it with a quantum accelerators, you can probably juice up quite a bit in the system performance.
Right, right. You just call a feature that's just like process visual frame or something equivalent. It's just like, oh yeah, just go do that thing.
Yes, exactly. So actually will be serving well with this embedded processor software market. And especially they are more and more pushing upstream, not just software, but all this algorithmic design. So this is a very important gateway to allow more and more innovation to be able to use FPGA. But once again, we are not Xilinx or Intel. We don't have plan to build like very fancy EDA tools.
Right.
We believe in making the workflow very simple, straightforward,
Hmm.
and it's inevitable in some part of the workflow to design in will require good engineers to build up certain things. But I think we are trying our best to make it very straightforward to allow varieties of innovators from all the way from RTL designers to software designers all the way up. I think right now the hardest is how to enable the AI developer when they
Yeah.
start their AI projects, or if they need an edge device, how they can make that decision upfront to make it them easier to use Efinix, right? So that's what we are working on. So
Yeah. Yeah, that's great. I mean, so on the tool side of things, I mean, so we've had people in the past that have been using like the open toolchain stuff. Efinix uses a proprietary toolchain right now. Any thoughts about the open toolchain stuff in the future to make it a little easier to have that quick iteration loop?
yeah, so I think this is the open tool chain is a very interesting topic. I actually not say we. I actually is the guy more neutral in this area. I mean, if you talk to some hardcore traditional FPGA guy, it's
Hmm. Hmm.
this is not going to work.
Yeah, I've actually had that feedback before too, and I was really surprised. I was surprised by it at first because I was so excited about the open toolchain stuff, and they just go, "Nah, that's not for me." And it's like, okay, well,
I think the combination of it is I would agree 50% of it is true. It is totally not practical when you start. As I said, if you just want to build something, you can build it. But if you want to build something super competitive, you have to harness both hardware, software, and architecture concurrently to build something good. That's where the core is. So that is hard.
yeah, so it's almost like a vertical integration kind of piece, right? So
Yeah,
it's like where you need to really focus in on something, you want to have that direct control of the whole stack. You're saying,
and it will be totally inefficient. I mean, I understand the spirit, but it's totally inefficient. People may spend 20 years to build something totally inefficient. So, but anyway, but as I said, I try to kind of in the middle. So, one of the innovations that we have, people may not be aware, actually is patented. It's our interface designer set up in our tools. I have to be careful. I haven't talked to my software uh, guru Jay
right?
Schleicher. No,
Is
no,
this
no,
actually out yet?
no. The pattern is there. It's in our tools. Our tools look different from standard FPGA because of the interface designer. We got a lot of complaints saying that, oh, how come you didn't make the tools looking like Vivado or Quarters? It's hard. So, but anyway, there was a reason for that because Jay and Jay is our software guru. I mean, it's without him we couldn't build Efinix. One of the key things is we are not building traditional FPGA. We are building a technology that want more and more things to interact with our core. So the concept interface designer is to separate the core away from the periphery and
Mm,
potentially anything attached and talking to our core can use this piece of software to talk to the core. And not now, but clearly that we envision some of our customer, and I don't know if you, we also have business people license our technology, which is
hmm.
public information. Our investor Samsung, we have built something very successful on 10 nanometer. It's on the silicon. It's a public. So
Oh,
I can
cool.
talk about it. So, but the role of interface designer is a choice that is a piece of software currently we use to harness the IO interface for defining the settings and so on. But clearly this piece of software is very expandable in the future. Not jumping into open source yet, but I think this is something that if our customers decide to build a hybrid devices, whether two chips, one chip, and find itself useful, we are more than willing to license the code to them. So
Got it.
I think that is more pragmatic way we think about start democratizing this kind of offerings.
Yeah. Yeah, I was wondering about that because you'd mentioned like being integrated in like to a SIP or something, and say, okay, it's reconfigurable, but you need to have the tool chain then so that someone can actually go and reconfigure that and make it useful.
But we already pre-built this for our own usage for our interface. This technology clearly can be a great technology when someone try to bridge a another AI chip together with our say
Mm-hmm.
TI 375. If they find it's useful, they can choose to license from us or buy the part from us. We can open to them, right? So that
Mm-hmm.
part of it is a technology. In old school, everyone will keep it in the closet, right? So when no one can use it. But the way I
I
personally
think
look at it,
in the old days they would have charged you a lot of money, like it'd be $100,000 seat for it as well.
yeah, but now is more like if more people know how to use, as I mentioned, that my channel, my ecosystem is different. I mean, I can see a lot of microprocessor company or people even building ASIC. They may want to early to decide to pair with our FPGA together as a product. So they may as well to offer a piece of software outside that can work with their system. So I wouldn't jump in immediately talk about this is a kind of open source, but it's kind of a trend that we allow more people can use the core technology.
Yeah.
Yes, I mean, but clearly in the industry, a lot of folks would envision or imagine that. I think it more belongs to the group that FPGA architecture never change. Why not just open source it? But they didn't realize that someone has already changed the equation, and
Mm-hmm.
then who
Yeah.
is us? So the core itself, it's a lot more sophisticated,
Mm-hmm.
and but open up the interface, be able to talk to our core. I think it's just a matter of time. So yeah.
Yeah, the way I kind of think about it too is when I think about like if I think about a graphics card like getting integrated into Linux, usually like the leading edge graphics card, you need some kind of special software to work with it just because it's got special features and that are not just standard yet. And then over time, it's possible that that kind of gets pulled upstream, maybe in an open source. It's not going to be leading edge, but yeah, it does. Some of the older stuff gets pulled in, so maybe it'll operate in a similar way. But I think what you're saying, what I hear you saying, is that because it's leading edge, it has these specialized tools that are required to just get the interesting things happening within the chipset.
Exactly.
Yeah.
I can see the trend, but I see in stages and adoption. And also one thing is we are just too small a company to
Sure.
try
Yeah.
to make anything open up to be successful. So
Mm-hmm.
when we this discussion, if it's 3 years later, I think we'll have a different look. But the goal is going back to the first thing we talked about. I mean, we believe that with this disruptive technology, with the timing, with arrival of edge computing slash AI, we really see a trend that Efinix technology can be everywhere. So
Yeah, that's great. That's great. Are there any interesting applications that people don't see coming that you're like, oh, they should keep an eye on this one? Do you see anything kind of on the horizon that might be bleeding edge that we're just not thinking about yet? So like maybe even vision being used for something that's unexpected.
actually, I have the answer. I almost kept coming out from my mouth, but I suddenly say I shouldn't tell my competitor about that. Because the competitors are good because they have the marketing, they have a channel, they can
Sure,
build
sure.
something not the best, but they can still sell, right? So I I think let's take a battle that we are not in, everyone in, then it's easier. I cannot tell the other one because I don't think they're good at that one yet. So, but I don't want to tell
Mm-hmm.
them.
Okay.
But let's take about automotive.
Mm-hmm.
I mean, automotive is going to be a truly explosive market. The reason is simple. I mean, everyone knows that. I mean, yeah, yes, autonomous car, ADAS, and
Yep.
all this technology and a lot of sensors. I think if you look at from a computing standpoint, this is a moving supercomputer, right?
Yeah. Yeah.
And also a can be a live advertising machine. I mean, your life spending in a car doesn't matter. It's a small car, big car, bus, whatever moving. I think there will be a new architecture, and mostly has to work with very strong software infrastructure and service.
Yeah.
So when you start looking at that, cost, efficiency, real time computing is important.
I could see the reconfigurability being very important too. Thinking about like, GM putting out a car tomorrow that might have a chip in it, but it's being expected to last for 15 years. It's like, okay, well, 15 years from now, like car components might hold up, but if the vision is still the same old pokey vision from 15 years ago, it's like, oh, well, we want to actually update like the vision that might be on board, or the algorithms that are actually controlling things, and having that reconfigurable nature might give it more lifespan than it would have otherwise.
Exactly. And normal wisdom is in the short term, just build another chip. As long as you have enough money, you can keep building custom chip.
Right, right,
But
right.
that's not going to work. And so our type of technology is extremely useful. I mean, once again, not saying that we can build the best AI or application processor or NVIDIA chip. No, we are not. But we could see that within a car, there are so many places would require very flexible, reconfigurable near data computing accelerators.
Hmm.
That's where the area is important. But hey, the worry of FPGA doing that, I guess the problem is under limited space. You think a car is big, right? But
Hmm.
the cost and the space and thermal is crazily critical.
Right.
A lot of thermal budget may already burn by some critical chips or other things, right? So, and I think we have a play in different spaces, different places in the car. I don't think today's car is already the car for the next 20, 30 years. I think there's a lot of innovation within automotive areas still to be seen.
Hmm.
So the market is actually not a, if you're a short-term startup, it's not a good market because it takes years to qualify to
Yeah.
be
Yeah.
and so on. But I think we already burned a couple of years, and we have an automotive offering starting this year. Titanium is perfect for that market.
Oh,
So
great.
I see
Like
that from
pre-qualified for the temp ranges and stuff like that, you mean?
exactly. Yeah, we
Yeah.
as I mentioned, there are multiple things that titanium is defined perfectly.
Hmm.
So I mean, say I don't worry to mention because I still think there are areas in the auto industry that will have so much innovations that this is the next big market we are growing into on top of our early success in industrial and consumer market. So,
That's great. So you mentioned titanium's on the way to market right now. You're in you're sampling and things like that. When is kind of the general public going to see these? I mean, so I was going to point people towards your dev kits page. People can get hands on with the Tryon parts, but what about the titanium that we've been talking about here?
I start thinking I'm leaking something here. So we as we speak, we are receiving POs from customers and try to get development kits. The development kit is in the manufacturing right now. I mean, we
Oh,
already
great.
get a
Okay.
number of them to show customers.
So are you held up just like everyone else because of all the supply chain shortage stuff? It's like you can't get the crystal you need to build the dev kits.
That's we are probably okay. We are probably
Oh,
okay.
good, good.
We
Yeah.
dodge around a few bullets in that problem.
Yeah, it's been a mess, right?
Yeah, it's a mess. So, but I think the Q2, we have multiple events worldwide that doing more sort of disclosing about the Titanium product. And we took an approach more, we have over 50 customers waiting for the device and some of
Oh,
them
awesome.
looking at it and but we are still a small company, so we are trying very
Right.
best to prioritize and It's an early sampling, so there are things that we need some hand holding. But we're
Hmm.
looking at summer as where the production will start. Then the exciting part is our next device will come up also in early fall or something in Q4.
And like another, like a third version that we haven't talked about yet.
Basically, today we have the first little brother TI-60,
Ah, got it.
which is a very small one,
Hmm.
3.5 millimeter square. So which everyone can use it. So we just open up a big adoption. But then the next one, it's I will let the our press release in April to talk about it.
Okay,
So
great.
we basically will get the most of the family members to be more ready, either production or sample by mid next year. These 2 years, our development pipelines are filled up already. So
Yeah. Yeah, I guess I didn't really think about that. Of like, yeah, you qualify. It's like you don't just release a whole family at once. Like, there's actually individual chips in there. You have to qualify and make sure each one's working as
yes,
expected. And
yes.
yeah.
And as I mentioned, the challenge and somewhat we are enjoying it is we very much try to build in an FPGA business. You're doing so many things, right? So we are
Hmm.
trying our best to pipeline each of the steps, and so that we can roll out products, develop an ecosystem, and open up channels. That's what we are enjoying, but nothing close to my old company experience. As I
Right.
said, the
Right.
old company may
Yeah.
do these things over the next 5 years rather than the next 2 years, right? So
Hmm.
with 10x more people. So that's what we are trying to do. It's kind of silly, but I
Right.
guess very very grateful. Our team members is kind of enjoying that, right? So yeah,
Yeah, I mean, it's like that scrappy startup, like fight the good fight and getting cool hardware out there. That's like the exciting part of it all. I think that's really great.
exactly.
Yeah.
But our challenge is not technology. Our challenge is not financial. We get great sub investors. Our challenge right now is actually how we turn a very organic company that people enjoying that kind of flexibility to a much bigger organization. I mean, if a company scale, you have to start putting in more process
Hmm.
system, but how to make that change without like suddenly break the key ingredients of the
That's
company,
right.
right? So that's where
Yeah, I
we are
think
working on. Yeah.
yeah, company culture. I think what Richard Branson talks about, like every time you go from like 3 to 10, like 3 to 10, 10 to 30, 30 to 100, like each time it's like a whole new company basically, or something like that. And then it keeps scaling like that, and you have to just try and maintain your culture, and like keep that scrappy mentality, and so you don't change what your customers are thinking about.
Exactly. I think that's fascinating, and we try to work on it. I mean, I don't think there's a perfect solution, but I still going back is let's focus on our own people, our own culture. And my
Hmm.
job is not trying to put a fixed formula on everyone. My job is try to see what I can get the best out of each one,
Yeah, that's great.
and push forward. It's still very much people oriented. I mean, startup is still very much people oriented. So
Yeah, yeah, totally. Well, Sammy, where can people find out more about you and about Efinix and all the parts, the wonderful solutions you have out there?
I think websites, and also we are pretty talkative on LinkedIn. I think these
Okay.
are the two venues that we see a lot of followers. I believe there we will be a lot more visible this year in terms of in different publications, stories, and so on. But I think the best way to learn more about us is get the websites. If you are developers with great ideas or have FPGA experience either, and also just click in the websites and find out how to get a development kit and start looking
Yeah.
into that, and you will find something very different from what was in the past. We try to build FPGA not just for a couple companies, but I think a lot of people can take advantage of this breakthrough in the industry, and we count on everyone to bring it alive. So yeah.
Awesome. Well, thanks for sharing about this, Sammy. I think you're a great spokesperson, and you're very passionate about this, and it was really great hearing about where you see Efinix and the FPGA industry going. So I appreciate you joining us today.
Thank you so much for the opportunity. Thank you.
While FPGAs allow for maximum flexibility in digital designs, we are able to be flexible with sending mics to our guests thanks to our patrons. They make interviews like this possible. You can become one of them by joining the crowd and the Discord channel at patreon.com/theampower.